I was going to check out this Velleman audio amplifier kit that I built, and it requires a power supply, and so I connected it to this new Siglent power supply that I bought about a month ago. Now, I'll be honest, I hadn't been using this power supply because I hadn't had any power supply projects. When I first got it, it appeared to work okay, but as you can see now, it has developed some serious problems, and I don't know whether these were there when I first got it, because frankly, I think this is the first time that I've applied a load to the power supply. But you notice that the current seems, this is supposed to take up to 14 volts with somewhere between 12 and somewhere around 10 or 12 volts as the ideal and a max of 14. So I have this supply set to 10 volts, but you notice that both the current and the voltage are jumping all over the place. So it's clearly not regulating properly. So anyway, I'm just doing this little video, and I'm going to have to postpone doing this amplifier check for now. Although what I may do is move over and use this other power supply, which I've had for some time and seems to work pretty well, at least for that. But in the meantime, this is in the evening, so I'm going to contact Schematic, where I bought this, tomorrow and see what they say, but I may wind up having to send this back. So I'll let you know with a little follow-up to this video, and hope that things will work out okay. Well, thanks to a helpful support tech at Schematic, I was able to fix the problem with the Siglent power supply. And I've decided I was going to do a review of the supply itself, but I was also going to use it as part of the review on this little Velleman amplifier. I'm going to go ahead and do that at any rate, but let me explain what was going wrong with the supply earlier. It turns out that the dip switches on the back that set the voltage were set wrong. Now, it explains, there's a description on the back of the unit, and in the manual it says, make sure your settings are correct and so on. But normally, at least in my experience, most American distributors, normally they're already set for 110 volts. Well, it turns out my unit wasn't. It was set for 220. The second problem was that the unit almost works. Even though it's set for 220, it almost works on 125 volts. The displays come on, you can set voltages and so on. You only discover a problem when you start putting it under load. So the mistake was mine. I should have checked the power settings. Kudos to Schematic for helping me find the problem. They were very responsive. When I sent them the email, they responded within an hour or two with good advice, and I've now been able to fix that. So I want to continue with some video on this little Velleman kit amplifier, talk about that a little bit, but then I'm going to finish up with a little mini review of this Siglent power supply. Now, I don't have a lot of experience with it. I bought it about a month ago. I initially just turned it on to make sure it would power up, and then turned it back off again to finish a bunch of other things I was doing. So I have not had a chance to really use this supply very much, and in fact, putting it on this little amplifier down here was the first real test of the supply, which is when I encountered the problem. So anyway, the egg is on my face. I should have checked those power settings in the back. Should have probably checked them when I got the unit. But at any rate, it seems to be working fine now, and I'm a very happy camper. So let's get on with a little bit on this testing of this amplifier. I've connected up the Velleman Amplifier Kit, and I'm sorry I can't show you the assembly of the kit. I actually built this kit months ago, but it is a kit. I assembled it I have not tested it before, but basically the kit, I'll show you the specs in a minute, at least the published specs. But what you see on the screen is the Analog Discovery 2. On the left is the scope over here. Down here in the lower right is the Waveform Generator. And so let's take a look at that. You'll see that the Waveform Generator is putting out a 1 kilohertz sine wave, 1 volt amplitude. And over here you see the two waveforms. Now I have offset them slightly. That is, I've applied a DC offset so that they don't sit one on top of the other, because they're actually identical. The tracking on the volume control is really good. This is a stereo amplifier. So one trace is the left channel and the other trace is the right channel, and I'm driving them with the same signal, so they ought to be identical, and they are. Then over here you'll see that I have a measurement that is an AC RMS measurement of 3.399. I'm going to call that 3.4 volts. So let's do some calculations, but before we do the calculations, we have to know what is that value taken across. So let's take a look down here at the amplifier. Pardon the sudden sweep there, but you'll see that what is on the output of the amplifier are a pair of 15 ohm resistors here. They're 2-watt resistors. So I'm going to turn the volume down now that we've taken that measurement of 3.34 volts. And now let's calculate the power output. Now here are my calculations. I got 3.34 volts. I calculate the power by taking the voltage and squaring it. Now that voltage is in RMS, or root mean square measurement, divided by the resistance that voltage is taken across in ohms. So that's 0.334 squared over 15. I get 0.743 watts per channel. Now, I have adjusted the volume, specifically not to overdrive the amplifier. As a result, this is about the maximum undistorted power you can get into a 15 ohm load. The specs on the amplifier I'll show you in just a second. I raised the power supply voltage to 14 volts, and I cranked the volume control up until it just distorted. Let me show you what that looks like. Now here is the setting I was using to get that measurement, and if we go up just a fraction, you see how it flat tops? That's significant distortion, so I'm just barely going to back off right there. And then let's read 4.13 volts. Okay, now let's calculate that power. This time I'm going to show it to you on the calculator. So we've input the voltage, 4.13. We're going to square that. We get 17.0569, and then we're going to divide by 15 ohms. And you see we get 1.1 watts. Let me make sure you can see the decimal point on that. 1.137. Now that's into 15 ohms. Most speakers, and by the way, the specification for the amplifier at the where right next to the speaker outputs says that it will work between 4 ohms and 32 ohms, and that's the reason why I chose 15, because it's sort of in the middle. Also, most headphones are going to be around that. A lot of speakers are actually down around 8 ohms, And we could go down and measure this at 4 ohms. The point is, even at 4 ohms, you're going to get significant distortion. As you saw earlier, when you turn it up to the point where you get a flat top, you're getting more power out. But frankly, the music sounds terrible. I've switched now to the network analyzer of the Analog Discovery 2. What you see is a sweep from 20 Hertz on the left to 100 kilohertz on the right. The top trace, or the top window, shows the gain. The 3 dB point is approximately here, which is about 20 Hertz. The gain is about 11.5 dB, that's this line. This is 8.5 dB, so 3 dB down would be right here, and that's roughly 20 Hertz, almost precisely 20 Hertz. Out at the right, the 3 dB point is about here, and that is about 60 kilohertz. So the 3 dB bandwidth of this amplifier is from 20 Hertz to 60 kilohertz. Now I'm just looking here at the specs again to see what they say. The frequency response says it's 30 Hertz to 100 kilohertz at 3 dB down into 8 ohms. So remember, we're working into 16 or 15 ohms, so that's a little different. But basically, it doesn't quite make it at the top end to the 100 kilohertz that the specs say. But it does better than the specs at the low end. The low end say that it should be 30, which would be about right in here. And at 30, it's only down about 1.5 dB. So the actual frequency response is not quite what the spec says. But I think for a low-priced audio amplifier kit, it's certainly adequate for most audio applications. Here is the cover of the kit. And you may notice it says it's a 2 by 5 watt amplifier for an MP3 player. The inside has the assembly instructions and some other things, and then on the back is a set of specifications. So I'm going to try to zoom in on those so we can see what those specs are. Okay, I hope you can read these. It says 2 by 5 watts, and then in parentheses 10% THD at 4 ohms, supply 14 volts. Well, what I'm doing is a little different. I'm using 12 volts into 15 ohms, and I'm getting a little bit less than 1% total harmonic distortion. So these are measured under quite different conditions. In my experience, 10% total harmonic distortion is bad enough that most people aren't going to want to listen to it at that level. Now, I realize that some people like loud rather than good, but for most listeners, I think you're going to find that you're going to want the total harmonic distortion down in the 1% range if you're listening to music that you really care about rather than music you just want to bounce the neighborhood. Here is the schematic of the Velleman amplifier. You'll notice over here there's a fair amount of filtering on the power supply, 2200 microfarads and 100 microfarads. Then an additional 100 microfarad right at the chip. The chip used is the TTT171. It says 20 dB. I don't think you actually get 20 dB into higher impedance lows. You might be able to get 20 dB into 4 ohms, but into 8 ohms or 16 ohms, I don't think you're going to get 20 dB of gain, partly because of the way these amplifiers operate, but I won't get into that. The inputs are coupled through 220 nanofarad capacitors, and then there's a 60 k ohm resistor across each of the inputs, and the power that comes in on pin 6 is pin 8 is dropped internally to half the voltage. So if you have, for example, 12 volts here, you're actually operating the TTT171 on half that voltage. The outputs are coupled through 1,000 microfarad capacitors to the speaker terminals. And of course the speakers don't come with the amplifier. These are just shown for illustration. So this is the schematic. I'm not going to go into the details of the TTT1517. It's been around for a while and is a reasonably good amplifier for audio applications. At any rate, thought you might like to see the schematic and a little bit of how the circuit is wired up. This is the Siglent SPD3303C programmable DC power supply. I bought this from Siglent, and as I indicated earlier, it seems to operate pretty well. I haven't had a lot of experience with it yet, but the reason I bought this supply, for those of you that have followed my videos, you know I used to have a pair of supplies here that I used for a lot of experiments, and I wanted something that was a little more convenient to use and also something that would go a little higher in voltage. Those two supplies, well, I had a 15 volt supply, two 15s, and a 20 volt supply. This will go up to, well, that's current, to 32 volts on the output. It's a dual channel, so you can have either plus or minus depending on how you have the outputs configured. 32 volts per channel. So we're on channel 1 right now. I'll go to channel 2 and we'll go up to the highest it can go, which is 32 volts. Then down below it is the current. When the supply is turned off, this is the current limit. When the supply is turned on, it reads the turn this back down to 14 volts here. There we are. It reads the current that's actually being drawn by the device. In this case, it's that little Velleman amplifier. And in this case, it's 0.04 amps. So you can set the limit on the current, and of course you can set the voltage. I haven't verified all the specs on this unit, but now that I have it set correctly for the correct AC voltage, which, as I said earlier, that was my error. It appears to work correctly. I've tried both channels. It also has a third channel that I think is going to be very useful over here that allows you to select 3 fixed voltages. The two that I'm likely to use quite a bit are the 5 volt channel for TTL logic and the 3.3 volt logic or level for low voltage CMOS. It also has a third, even lower voltage. I think it's 2.5 volts. Now, if you look at in addition to the adjustable controls, let me turn on some more light over there, you'll see that it has a button to select a particular channel or a storage location up to 1 to 5. You can recall from that location and you can save into that location. You can also lock the keyboard, but these two keys are one of the reasons I bought this supply. This key allows you to put the two supplies in series, so you can get up to 64 volts when you're in series. You can also put the two in parallel. And now you could do this by rewiring as well, but the nice thing about these buttons is it does it for you behind the panel. You can put them in parallel. So suppose that you wanted to, let's see how high the amperage setting is. I think it's 3 amps. Well, 3.2 amps. But if you wanted up to 6.4 amps out of this supply at up to 32 volts, you can do it by hitting the parallel key, and the parallel key puts the two supplies in parallel. And so you're getting 3.2 amps from channel 1 and 3.2 amps from channel 2, or a total of 6.4 amps. So this is sort of a mini review of the Siglent SPD3303C power supply. For those of you that might be interested in a little more of a review than what I have done here, I suggest you look at the excellent video that John Audio Tech did on YouTube. But in the meantime, as far as this is concerned, I'm going to close this video and wish everyone a nice day.